Don't forget to subscribe and ring that bell.
Hey man, welcome aboard this ship as we travel down the 2014 AP Calculus AB practice exam that College Board was so generous to give to us, to practice with. We are starting today, which means we are going to start with section 1, part A, start with problem number 1. We are going to do multiple choice problems 1 through 10, and oh boy, we don't get a calculator, which is fine because we're smart. And hey, like the video, ring the bell, leave a comment if you want to see some other things. Let's get started. Number 1, integrate from 2 to x, 3t squared minus 1. This is very simple. Do not overcomplicate it. You are not just going to replace your t with an x. You are not taking the derivative. If you were taking the derivative, these would cancel and the x would go in for t. All right? But on occasion, you have to actually plug an x in for a bound. Let me state that again. You are not taking the derivative of an integral. So do not just replace your t with an x. We're actually going to integrate this. All right? 3t squared. I add 1 to the exponent. Okay, and I divide by that new exponent. These cancel, so I get t cubed. The second thing, minus 1, I just add an x, so it's just 1x. Well, t, I guess I should call that, because we're working with t's. Minus a t. I want that from x to 2. All right? If you notice my options, my answers, they all have an x in there. So it's fine that we have an x. All right, let's plug x into our t's first. So it's x cubed minus x. Okay, minus plugging in the lower bound of 2 here. 2 cubed minus 2. Well, this is 8 minus 2, which is 6. Bring that minus sign down. X cubed minus x. Very simple to start. Don't make any simple mistakes by going fast, but our answer is choice A. Number 2, what is the slope of the line tangent to the graph of y equals ln of 2x at the point where x is 4? Slope, oh my goodness, is the same thing as derivative. All right, so let's find the derivative of our function at the point where x is 4. The derivative of the ln of 2x. Okay, if I want to take the derivative of this, the derivative of natural log is 1 over whatever's in parentheses here. But let's not forget our chain rule, times the derivative of the inside. The derivative of 2x is just 2. All right, well, let's simplify that. We have 2 over 2x. These cancel, and I end up with 1 over x. I want that at an x value of 4. So I'm just going to plug in a 4 for the bottom. Booyah. That, my friends, is choice B. All right, problems 1 and 2. They're not that difficult at all. We're moving. Problem 3, if f of x is 4x raised to the negative 2 plus 1/4 x squared plus 4, then find f prime of 2. Again, simple derivative problem. Let's just go right down our line here and take the derivatives. Who cares if we have a negative exponent? I'm still going to bring that down and multiply it, and then subtract 1. Negative 2 minus 1 is negative 3. It is not negative 1. Don't go fast and make mistakes. Plus, okay, now I'm going to do the second term. My 2 for my x squared comes down, times 1/4 x, and I subtract 1, and this 2 becomes a 1. The derivative of a constant, bye-bye, goes away. All right, let's clean this up before we throw in our 2. We got negative 8 x to the negative 3 plus this goes into here twice 1/2 x. Right, let's clean this up even more. Okay, I'm going to make that negative exponent positive. I don't mind dealing with negative exponents. I prefer it when we're taking derivatives if I have to sometimes. But when I'm plugging a number back in, I like to make it positive. So let's keep in mind that this is technically over 1. We're looking right down here. I'm going to flip this and make that a positive exponent. So negative 8 over x to the positive 3 plus 1/2 x. And I want that at an x value of 2. All right, well, let's start rocking and rolling here, friends. It's 8 over 2 cubed plus 1/2 of 2. All right, well, 2 cubed is 8. Okay, negative 8 over 8 is negative 1, plus half of 2 is 1. Man, did we get 0? Did we get choice D? 0? We did. Look at us. Not too shabby. It's just these first 10 multiple choice problems typically aren't that difficult. You just can't make simple mistakes in your algebra. Number 4, the integration from 1 to 2 of dx over 2x plus 1. First of all, I like to move that dx off to the side, and I like to just call that 1 over 2x plus 1 dx. I don't have to, but as I'm teaching, I do that anyways, especially if you're new to this. Now, some of you can integrate this and realize it's going to be natural log, and that 2x on the bottom is going to create a 1/2 out front. Some of you might look at that and say, what did you just say? And for those of you that say, what did you just say? I'm going to use U substitution, all right? But this is a simple U substitution, simple enough that some of you might be able to do it without the U substitution because you know what's going to happen. All right, I digress. U is going to be 2x plus 1. The derivative of U is just 2 dx. All right? So what I'm going to do now is I'm going to take my U here, okay, and substitute it in for 2x plus 1. So I have 1 over U. Okay? But notice that for my substitution for the du, I just have a dx. I don't have the 2 dx. This is where that 1/2 comes into play. I'm going to multiply both sides by a half. How come? This half cancels with 2. So now in for my dx, which is here, I'm going to put 1/2 du. I'll put my constant on the outside. And there you go. There's one thing left I need to do. Since I have bounds, and these bounds are in terms of x right now, x equals 2, x equals 1. I want them in terms of u, and I have to use this right here to convert them. If my upper bound is 2, and I plug a 2 in for this x, 2 times 2 is 4 plus 1, my new upper bound will be 5. We got to do the same thing for our lower bound of 1. Okay, if I throw a 1 in here now, 2 times 1 is 2, plus 1 is 3. All right, so I want that. Well, yeah, I'll be okay. We want that from 5 to 3. Now it's just a simple integration. The integration of 1 over u is the ln of u. I want that from 5 to 3. And by the way, let's not forget that we're multiplying that by a half. All right. 1/2 the ln of 5 minus the ln of 3. There we go. That's it. We're done. Choice E. If you are new to these videos, you have not heard me say this yet. I love me some graphs and tables and charts. Oh my, I love them. Eat them up. And number 5 gives us just that. They give us this beautiful little graph here. And 5 reads, the figure above shows the graph of the function f. Which of the following statements are true? Okay, and here are my statements. I listed them off to the right here. And then here are the options to pick from. A through E. All right, so let's look at the first one. We will do this in blue. First one. The limit as x approaches 2 from the left is the same as the point f of 2. Here's 2. As I approach that from the left, there's actually a point here. The limit is -1 on the y-axis, okay? And the actual point is at 2, -1. That's right. So that is true. True. All right, let's go here. Let's erase this, and let's take a look at the second one. All right. The second one now I'll do in red. The limit as I approach 6 from the left. Okay, here's 6. As I approach it from the left side, that also has a limit of -1. Does that equal the actual limit as I approach 6 from the right? Woo. Maybe. The right side is coming this way. That also approaches -1. That's good. All right. Doesn't matter if it's a hole or not. It's what it's pointing to. Okay? So that is true. Again, let me say that one more time if you don't understand limits. I don't care if there's a hole here or not. It's just what we're pointing to. They're both pointing to that same hole, which is at -1. Okay? Does not have to be filled in. A limit does not have to be continuous. It can be a hole. So speaking of green, let's do number 3 in green. So right now I know 1 and 2 got to be my answer. It can't just be 2, and it can't just be 3. Maybe it's C. Okay? It can't be D because 1 has to be in there. Okay, choice 1 in blue. So it's either 1 and 2 only, or it's 1, 2, and 3. Okay, the third one says the limit as f of x approaches 6. We just did that up here. The limit as I approach 6 from both sides is -1. Does that actually equal the coordinates? No, the coordinate is way down here. When x is 6, y is -3. So it does not equal the coordinate. This one is false. It's only 1 and 2, which means option C is the correct option. Number 6 is a very good early question. It's a great question that they should put early in the test to get your calculus and mathematical blood flowing. All right? The derivative of sine of x squared cubed. What I tell my students is every time you see this, you're cubing the whole thing. Meaning, and I tell them to rewrite it just like this. I have the sine of x squared. The whole thing is cubed. And we are going to have to do a double chain rule here, okay? Because there's 2 insides. What do I mean? Well, the first inside is the sine of x squared. Because look, on the outside is this. I got to deal with the outside first. There's another inside. On the inside of the blue highlight is x squared. Okay, so I'm going to have to I have 2 insides, so I got to do the chain rule twice. And I always tell my students, start with the outside and work in. So let's do the derivative power rule. I have this thing here. I don't care about what's on the inside. That's going to stay the same. All right? My exponent, which was 3, comes down, and then I subtract it by 1. I need to multiply that times the derivative of the inside. Now, the inside has its own inside. So forget right now about my 3 and my 2. Just focus on that blue highlight. I'm going to take the derivative of the outside of just the sine, and I'm going to leave this inside the same. What do I mean? The derivative of sine is cosine, and I leave the inside the same. Now, I need to take the derivative of this inside, which is 2x. Okay, so double chain rule. This is the derivative of this part of the inside, and then this is the derivative of this part of the inside. Double chain. So let's take a look. They're probably going to multiply that 2x and 3 together. 3 times 2x. They put that out in front of 6x. And then I have the sine of x squared. That's squared, but they write their 2's here. So let's put it back. Times the cosine of x squared. This is your answer. And if I'm looking, that looks like it's, is that choice E? Does that look like it's choice E? It looks like it's choice E to me, and it is right there. Very good question for early on in the test. Guys, 7 is a no-brainer, okay? I'm going to plug infinity in for x. First of all, can I reduce my fraction? No, I can't reduce this at all, okay? So I take the biggest term on the top and the bottom, and the top and bottom only have one term. I only have x cubed over e to the 3x. So I'm going to just plug in the infinity, all right? Infinity cubed is still infinity over e raised to 3 times infinity is e to the infinity. 3 times infinity is infinity. So the problem is, oh, I have infinity in the top and bottom. Do they cancel and become 1? No, they don't. Okay? We need to see which one of these, the numerator, or the top of the fraction, or the denominator, which is the bottom of the fraction, grows faster. The top just counts 1, 2, 3, 4, and so forth. The bottom, e is a number. It's 2.718. Let's round it to 3. It's 3 to the 1, which is 3. Then it's 3 squared, which is 9. Then it's 3 cubed, which is 27. This grows a lot faster. So if the bottom, my denominator, is growing faster and faster than my top is, the fraction will eventually become so small that it looks and basically becomes 0. Exponents grow faster than normal numbers counting. I shouldn't say normal. But then just counting by ones, exponents grow faster. Okay? Number 8. Using the substitution u equals sine of 2x. Oh, they give us this. Man, they might as well just give us credit for this problem. The integration of pi over 6 to pi over 2 of sine of 2x to the 5th power cosine of 2x is equivalent to. All right, well, I think I just gave my class this type of review problem. Let's rewrite this so it's a little bit simpler. I think I said a few problems ago, maybe it was problem 6. Yes, it was problem 6 where we had a chain rule, that anytime I see this, I always have my students rewrite it. So I've got the integration from pi over 6 to pi over 2 of the sine of 2x to the 5th power. I have them write it like this on the outside. So it's easier to do the power rule and chain rule. Times cosine of 2x dx. All right? So this is equivalent to which one of these using the u substitution that they give us, sine of 2x. So if u is the sine of 2x, du is cosine of 2x times 2 dx. As I look to my integral, what I have, this becomes u to the power of 5. That's nice. Cosine of 2x dx will go bye-bye. But look at cosine of 2x dx. I don't have this 2 here. I've got to get rid of it from the right-hand side. So I'm going to multiply by a half to one side and a half the other. So in for my cosine of 2x dx, I'm going to put 1/2 du. Of course, I'll put my du here, and I'll put my 1/2 outside of the integral. You need to change your bounds. You need to change your bounds. Right now, okay, right now, this would be wrong if I just put pi over 2 as the upper bound and pi over 6. These are currently x equals. Okay, we want them to be u equals. Right? So I go right here. All right, and I plug in the x's and convert it to u. So if x is, I'll do this down here. Okay, so u equals sine of 2x for my upper bound, which is pi over 2. That means I'll take the sine of 2 times pi over 2, and the 2's cancel. So really it's just a sine of pi. You should know the sine of 180 degrees. Okay, you should know that. All right, I ain't even going to play. That should be 0. So my new upper bound is 0. All right. If I look at that, look at my upper bounds. I can really, the upper bound is 1 here. The upper bound is 1 here. The upper bound is 3/2 here. All right. There's really only 2 options, D and E. All right. So I guess we got to convert our lower bound, which is pi over 6. If x is pi over 6, that's the sine of 2 times pi over 6. This will reduce to pi over 3. You should know that pi over 3 is 60 degrees. And you should know that the sine of 60 degrees is radical 3 over 2. If you don't know that, you better know your unit circle or your special right triangles. You need to know this stuff. All right? So my lower bound is the square root of 3 over 2. This is the equivalent to what we started with, given this is our u substitution. And if I'm looking at this, there's only one difference between choice D and choice E. What is out front? We have a half out front. We do not have 2 out front. Choice D. Number 9. Number 9 says the function f has a first derivative given by f prime equals x times x minus 3 squared times x plus 1. At what value of x does f have a relative maximum? Remember, in order to have a maximum, you got to have a positive first derivative, which looks like it goes up, to a negative first derivative, which goes down, and you should have a critical point where your first derivative equals 0 right in between. So I'm looking really for a positive first derivative to a negative first derivative. All right, and I do that personally on a number line, and I need to first find my critical points where my first derivative is equal to 0. So I'm going to take x times x minus 3 squared times x plus 1 and figure out where they're equal to 0. Well, this one right here is when x is 0. I solve them individually. Okay, x minus 3, there's only one value of x that makes that 0. That's when x is actually a positive 3. And for this right here, when x is negative 1, I have a 0. Okay, so there's 3 points, 3 critical points, okay, where my first derivative is 0. Here's my number line. X, my derivative, at negative 1, 0, and 3. At those 3 x values, my first derivative is 0. Now, let's just check some points in between. And I don't know, let's try some easy things. Meaning, let's try 4. If I throw a 4 into all these x's, okay, and the beautiful part here is, you see this middle? Let's look up here. Let's look in the problem right here. You see this middle one? It doesn't matter what I throw in for this x because I'm squaring it. That will always be positive. So this will always be positive no matter what I throw in. I'm multiplying it times x plus 1, and then times an x, okay? Because here's my x, and here's my x plus 1. All right, let me use the highlighters in case you're not catching it. This will always be positive, so that's good. I really don't even have to check that. It's always positive. But I'm multiplying it times an x plus 1 and times an x. So I really just need to check plugging a 4 in here and here. All right? Well, if I throw a 4 into both of those x's, a positive 4 times, well, 4 plus 1 is a positive 5. That's positive value. I don't care that it's positive 20, but it's positive. So on the right side of my equation, these are going to be positive first derivatives. So this will be going up the slope. Let's check, I don't know, the number 1. Again, if I throw a 1 into these x's, a 1 into this x on the left would give me a positive 1. A 1 here, 1 plus 1, well, that's 2. It's a positive 2. Again, a positive times a positive will give me a positive. So if I look at that right side of my equation, I really will make this a 4 again. I have a positive, then it flattens out, but then it keeps going positive. That is not a min or a max there, okay? So let's check some other values. Let's check, here we'll call it negative 1/2, all right? Again, this side here, that would be a negative 1/2. And if I put an x, a negative 1/2 here, plus 1, that's a positive 1/2. Okay, a negative 1/2 times a positive 1/2, that would give me a negative value. So this slope's coming down. So right here, I have a minimum at 0, not a maximum. They're asking for a maximum. So it looks like by default, my answer should be A, but let's check it out. Let's pick, I don't know, negative 2. If I throw a negative 2 in for this x, I get a negative 2. If I throw a negative 2 in for this x here, I get negative 2 plus 1, which is negative 1. I multiply a negative times a negative. There's my positive. Boom, that's up, which means I have a max at x equals negative 1 only, and that's choice A. All right, number 10. Let's end this poop show with number 10. All right, they give us this piecewise function, f of x above, and they say let f be the function defined above. For what value of b is f continuous at x equals 2? All right, so first of all, it looks like there's a discontinuity here. See, x can't be 2 here. And then they have maybe a separate point here somewhere else. All right, it looks like there's definitely a hole somewhere. All right, and so I got to figure out, well, what value of b would make it so that this actually is equal to 2. Okay, that would make it continuous. Right now, I have this line where x equals 2, and there's a hole here, and then it continues like that. All right, so what value of b makes that hole filled in? How do I know algebraically that it's a hole? Well, let me take that x squared minus 7x plus 10, put it over b to x minus 2. Okay, that top factors, kids. Factoring never goes away. The top is x minus 5. Where am I? Okay, minus 5 and x minus 2. Okay, if I cancel anything that would have made my function undefined, it is not a vertical asymptote. If I cancel it, x equal 2 would have made this undefined, but it's gone bye-bye. That means there's a hole here. Okay, that's how I can verify. So what am I left with? X minus 5 over b. Okay, where would that equal? All right, where would that equal 2? All right, let me see. So, I'm sorry, I'm saying where that should equal 2. That's at x equals 2, but I want it to equal this y output of b. Okay, so let me restate that one more time. Where will this output, what value of b, when x is 2, would make it so that the y output, that these two expressions are the same? So that's why I set it equal to b. Well, first of all, let's put a 2 in there. 2 minus 5, because that's where my x was, over b equals b. Negative 3 over b equals b. This will never happen. This will never happen. Never, 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 ever get back together. Never. How come? I mean, I could say it's non-existent. There's another way I can prove this if you should so choose. If I have negative 3 over b equals b, and I multiply both sides by b, right? I get negative 3 equals b squared. And I take the square root. There's your error right there. Okay? I cannot take the square root of negative 3. It's an imaginary number. Remember algebra 2 when we did imaginary numbers? It's technically I radical 3. But it's not a real number because there are no real solutions. Okay? But this right here should be obvious. Okay? There are no real solutions. We are done. Thanks for hanging around for a little bit. And like the video, follow me on YouTube. That's how you know when I put up new videos. Leave me a comment of other tests you may want to see. And in the meantime, I'm just going to continue this 2014 practice exam. I'll see you guys later.
Don't forget to subscribe and ring that bell.